I would still replace those capacitors because they're notorious for going bad. But the other thing you notice is that there's no frying egg sound. Okay, well, we have the board installed now. It was pretty simple. It's just connected on each corner by a little screw. One thing to look out for is they use spray foam to anchor the screw mounts, and if you take these screws out a little aggressively, you end up messing up the anchoring. So these anchors might need to be glued in later. Maybe yes, maybe no, but they're definitely not in the best shape in terms of like being secure, and that's a very high voltage coming into this side, so you probably don't want your board flopping around like that. It's not good, so we might have to secure that board later. So like I said, the high voltage connectors, a 3-pinner. It's keyed, it can only go on one way, and it goes right there. Pretty easy and simple to install. You just push it on. Let's get it in frame there. You just line it up and push it on until you hear a click. Or not. It's on, but it didn't click. There. That's most likely the board moving around. Now, the one thing you should probably do with a connector like I have for power is check to see if the fuse inside the plug is good or not. So when you're troubleshooting electronics, at least when I am, I start from the wall. I make sure I got power coming out of the wall, and then it's got to get through this plug, and this plug has a fuse built into it. Now, the other thing you could do is you could probably stick the probe of a multimeter into the back of this connector here, like so, like that, and see if you got juice. So we're going to give that a try. There's one for the top and one, oops, there we go, one for the top and one for the bottom. So those are plugged in, fairly secure. So let's plug this unit in, which I'm going to do now. Should I do it now? Maybe I should turn the power off at the plug, plug it in. Okay, so here in Hong Kong we have plugs with power leads on them, so you turn that off, plug it in. That plug is not energized yet, so we're going to put our finger on the switch, look at the unit, make sure we get no white smoke, and turn it on. And what do we hear? We hear a horrible buzzing sound, and we see two lights on, which means power is getting to the board, but something is seriously unhappy in there. I don't think that that's a normal noise. So we're going to turn off the unit. And that little buzzing sound went away. And the next thing we're going to do is plug in the display. Now, as you can see, the display is also keyed. It's a 3-wire cord, and it can only fit one way in the board. And if you look at the way the weight of the board has been, or the weight of the wiring harness has kind of taut this cable, chances of it going in this way are super, super high. So let's plug it in. Just like that. Okay. Now that's plugged in. What happens to the front of the machine? Well, let's turn it on to hear that crazy buzzing sound. And what does the front of the machine say? The front of the machine says 12. So we actually have a display. Interesting. So that means that we have voltage going to the display and it's detecting something. Okay. And now we're at the 3 2-pin connectors. We have one here. I don't want to stick my finger in this board at the moment. And we have 2 there, a black and a white. So I'm going to run away to the internet and see if I can find a photo of this board plugged in to see if I can get the right wires in the right place. I'll be right back. Well, after a bit of quick research on the internet, I've discovered the following. First of all, I got a little bit of light in here. So the black connector, as you can see, says fan 2. So the big question, of course, is where is fan 1? Well, if you take a real quick look inside there, you see fan 1 there. So what do we know about the fans? Well, they both probably run on the same voltage, which means that the red and black, which is a fan there, and the black and yellow, which is a fan there, are both fans, which only leaves the black and black to remain to fit into the connector that's labeled NTC1 right there. And I'm thinking that's the thermostat. So let's get this light back in there as best I can. So what are we going to do? We're going to connect the NTC1 because it's the lowest one. So we'll get our black and black connector, which is also, when you think about it, right? Which one's the shortest? So which one should probably go in the bottom? Which 2 are pretty much the same length and should go in the top? Yeah, so, but you know, abundance of caution and all that stuff. So let's plug in NTC1. There's NTC1. And from the diagrams I've seen on the internet with this thing plugged together, fan 2 is yellow and black because it's also a bit shorter. So okay, we'll just plug that guy. Right, plug him right in where he's supposed to go. There we go, NTC1. And oh, sorry, that's fan 2. Pardon me. And then we have fan 1, which is right there. So plug it in. Alright, so we have, let's make sure they're all seated nicely. Fan 1, fan 2. This is the display. Get these wires out of the way. Display. Thermostat. Now, doesn't that make sense? We need to tell the user what's going on. We need to test the internal temperature of the cabin of this cooler. We need a way to adjust the temperature of the cabin of the cooler. And finally, we need some way to provide cooling using this Peltier technique. So as we know, take a quick look, the top connector says minus, and the bottom connector, if you can see just below it, says plus. Well, they've been very thoughtful, and they have given us color-coded leads. So we have a black and a red. So the minus is on the top. Let's go with this one first. It goes all the way up, and simple. It's just a simple blade. Ooh, I've got to find them. There we go. Blade type connector. So it just slips over there like a car connector. That's one. And then we have the positive red wire. See, red wire. And it's, interestingly, its insulation doesn't go all the way to the end. That's probably no good. Oh no, the same thing goes. Maybe. Let's just see if we can sneak it up there a bit. I might need. Well, let's see. There. I can bend that up a little bit to keep it out of harm's way because there's a couple of diodes underneath. Okay, so now we have, one more time, this provides, these two leads provide power to the cooling plate located inside this fancy heatsink. There's a plate in there that gets cool when you run power through it using the Peltier phenomena. You can look it up on Wiki if you like to know more about that. It's a very cool way, pardon the pun, of keeping devices cool, and it's used in electronics a lot. But it doesn't provide a great amount of cooling, unlike gas or liquid cool. But it's pretty good for like low stuff or long-term stuff. So a wine fridge would make sense. You don't open it that often. The air volume is not that large. If you put a bunch of insulation in there, you can maintain a temperature fairly easily, like a fridge. And you have a lot of time. You don't want it to be loud, because it's going to be in the fridge, or it'll be somewhere public. And maybe ultra low noise. It's also much cheaper than a compressor and Freon or liquid cool in other senses. So here's the fans. So now we know one's red and black, one's yellow and black. That just might be for ease of assembly in the factory. They could both be red and black. Doesn't really matter which one I think gets plugged in first, but okay, fine. We have a display here. Looks like a 2-wire display to me with a ground. So there's a reference. Well, there's 3. There's a red, a black, and a white. So it's interesting. There's a lot of information being passed. So there's probably a microcontroller on the other end of that communicates with. And then we have almost certainly, this is the thermostat. Really, it's just a thermal resistor whose resistance changes with temperature. And what's happening is the little microcontroller chip here, which is programmed to run this guy. I wonder if it's a PIC or an Atmel. It's one or the other, probably. And it's been programmed to monitor the temperature using the resistor. If the temperature is above some preset value, it turns on the fans and power energizes the Peltier plate until the temperature drops to a certain level, at which point it tells the fans to turn off. Or it tells the plate to turn off and it runs the fans until the plate hits ambient temperature. Something along those lines. Now, where do these things fail? Well, I'm seeing a lot of attention being given to this capacitor and this capacitor. So those are the ones I'm going to probably change. They're not expensive to change, they're not hard to change, and they seem to be, as with most power supplies, the capacitor is what goes. And those big can capacitors tend to go early. So they're nothing special. I should be able to pick those up online, really easy. Change them out. I'll show you how to do that. But first, let's energize this unit now that it's completely wired. See if we get any magic smoke. If not, great. Maybe even the fans will kick in. They should, because the fridge is quite warm, way above what it should be. So let me just clear the area. I guess we don't need these leads, considering that it's turning on. So fairly simple and easy to say it's working. And here we go. Put the finger on the switch and contact. Actually, let me just do this with the right focus. Okay, so what we've done is remove the leads these two to the Peltier plate, which is inside this big silver can, and I'm going to energize the board. Now, why would I do that? Why did I unplug those two? Because these little guys here don't draw any power at all. The fans might draw a little bit, so yeah, but they don't draw anything like these leads. Look at the gauge of the wires. Those are some pretty heavy-duty wires, right? To carry some heavy-duty current. So the thickest wires here are for the incoming power. Those are rated for 15 amps, something like that, 10 amps. They're rated for full circuit voltage and current. 220 volts, 15 amps. That's a lot of power. Well, that's why those wires are so thick. And then we have the next thickest set of wires are for the cooling circuit. They're pretty hefty. And then we have these little thin guys. So why would a board not work? Well, maybe because something is drawing too much current. So that was my deduction. Anyways, let's turn it on and see what happens. If this thing turns on, then probably the power board is okay. It's the cooling part that's not okay. So let's see. Very interesting. We got powerage, we got fanage, but we do not have coolage. So whoever was troubleshooting this box concluded the wrong thing. The board seems to be okay.
I hope you liked this video. If you did, please consider subscribing, giving me a like, and leaving me a comment. I really enjoy making these videos, and I want to know from you how I can make them better. The whole point of these videos is to demonstrate that if I can do something, you can do it too. Well, that's it for now. So long, and remember, keep making.